Today we're looking at doubling and halving. Now you should remember from our work in class that doubling means adding the same number twice. So for example, adding 2 to 2, or adding 3 to 3, or adding 4 to 4, and so on. And that means that I am doubling that number. I am adding it twice. I am making it a double. So what about halving? Well, halving is the opposite, and halving is splitting something into two. So if I wanted to split the number 4 equally into two parts, I could draw two boxes like this to show my two parts, and I could equally share the number 4 between those two parts. So 1, 2, 3, 4. Now you can see that there are 2 dots in this box and 2 dots in this box, which shows that I have split the number 4 equally into two parts, or in other words, I have halved it. Okay, I now want to look at the numbers 2, 4, 6, 8, 10, and 12. I want to see if I can split these numbers in half with nothing left over. So let's start with the number 2 first. So I'm going to draw my 2 boxes to show my 2 parts, and I'm going to split the number 2 equally between my 2 boxes. So making sure I put 1 in one box and then 1 in the other box. 1, 2. I can clearly split the number 2 in half. There's 1 in this one and 1 in this one. So I'm going to give the number 2 a tick because it can be halved. What about the number 4? Let's try. 1, 2, 3, 4. 2 in this box, 2 in this box. So I can split it in half. So I'm going to give 4 a tick. Let's try the number 6. Now notice that I am taking it in turns between my 2 boxes to make sure that there are equal parts in this one and in this one. So let's try. 1, 2, 3, 4, 5, 6. 3 here, nothing left over, so 6 can be halved. Now for the number 8, I'm not going to bother rubbing these out because I know I've already drawn 6 dots. So I know that I can just carry on counting. So 6, 7, 8. 4 here, it can be halved. I will give it a tick. Let's carry on with 10. I've already drawn 8 dots, so now I know that 8 plus 2 is 10. I just do 9, 10, 5 and 5. I can give 10 a tick. Same for 12. I know I've done 10 dots already, 11, 12. Nothing left over, so I can give 12 a tick, which means that all of these numbers can be halved equally. Now these numbers here are all called even numbers. They can be evenly halved. They can be evenly split into 2 without anything left over. So what about the numbers in between? Well, I now want to try 3, 5, 7, 9 and 11. So let's see if they can be easily halved just like the numbers above. So I'm going to draw my 2 boxes and start with the number 3 using the same technique. 1, 2, 3. Okay, I can see already that there are 2 dots in here and 1 here, which means that the number 3 cannot be equally halved. So I'm going to give 3 across. What about the number 5? Well, I'm going to use the same method as I did above and carry on counting. So 3, 4, 5. Okay, once again, 3 here and 2 here. So 5 cannot be halved equally. What about 7? 5, 6, 7. I'm starting to see a pattern. Every time I add another 2 numbers, I've got the same problem where I've got more in this box than I do in this box. So 7, again, cannot be halved. And it's the same for 9 and the same for 11. Now, these numbers here are called odd numbers. And it shows you that there is always an odd number left over. They cannot be evenly halved. So my challenge to you now is, can you think of a rule for halving odd and even numbers?